For the volume and mass flow measurement of liquids or gases, JUMO offers different methods. Together with the customer, we find through a consultation a suitable solution for his measuring point. In this video, the features of the various flow rate measurement devices are shown, as well the commissioning by reference of a practical example. The JUMO product portfolio includes the following devices and accessories for the flow measurement. The pedal wheel sensor and the insertion MID sensor are so-called plug-in sensors. The FlowTrans Max series covers the wide range of applications, and the P20 Delta is used for the differential pressure method. The pedal wheel flow sensor is in the lower price segment and suits for non-aggressive and low viscous liquids. It is supplied with special armatures, which are suitable for pipe diameters from DN15 to DN400. These are ordered in stainless steel or plastic, depending on the application. The pedal wheel sensor measures the flow mechanically and outputs in frequency which is proportional to the flow. This insertion sensor works according to the magnetic-inductive principle and represents a particularly compact type of the MID technology. It is combined with the same armatures as the pedal wheel sensor, but the measuring principle is completely different. The sensor works without mechanical components. By emitting a constant magnetic field in the sensor tip, according to Faraday's law, a voltage is induced by the flowing liquid. This voltage is tapped at two electrodes, which are also embedded in the sensor tip. So the sensor is wear and maintenance free. The temperature and pressure range is significantly larger compared to the pedal wheel sensor. However, the liquid must have a minimum conductivity of 20 microsiemens. The JUMO FlowTrans Mag is a magnetic-inductive flow meter for liquids in industrial and hygienic applications and processes. This unit features maximum accuracy and user-friendliness. The measuring principle is the same as the insertion MID. However, the full pipe cross-section is used for the measure, whereby an accuracy of up to 0.2% deviation from the measured value is obtained. By the installation of those devices, there is no additional pressure loss in the system, since no interfering contours or constrictions are presented in the measuring tube. It is available as a standard model S01 with flange connection, as well as an hygienic variant H01 with corresponding process connections. The device is composed of the transmitter and the measuring tube with an integrated sensor and must be ordered for the respective pipe diameter. The sensor is available in various linings and therefore suitable for a variety of applications, even for viscous or highly abrasive media with a minimum conductivity of 5 microsiemens. The JUMO P20 Delta is a differential pressure transmitter for the process industry with highest precision. Using a primary element like a pitot tube, the P20 Delta is able to constitute the flow rate by calculating the square root of the respective differential pressure. This method is applied to liquids and gases and can be used under extreme conditions, for example saturated steam measurement. The primary elements, for example an orifice plate or pitot tube, and also essential accessories are offered by JUMO. With the following example, we show you the selection and commissioning of a flow meter. A paper mill wants to measure the flow rate of pulp in an existing plant. The pulp is fed into a pipe with DN65. The pump capacity is 11 cubic meters per hour. The space available for the installation of the measuring point is limited. A straight pipe section with 1 meter length is provided for this purpose. Each flow meter requires a most possible uniform flow profile. Therefore, so-called inlet and outlet sections are needed to calm the flow after being swirled by bends, taperings, valves, or has been undergone angular momentum. This in- and outlet sections vary depending on the measuring method and can be up to 50 times the nominal pipe diameter in the worst case. For the Flotrans MAC, an inlet section of 3dN and an outlet section of 2dN is generally sufficient, since the magnetic inductive method always recognizes the full pipe cross-section and thus is less sensitive to inhomogeneities in the flow profile. Due to the viscous medium and the limited space, the decision is made for the magnetically inductive flow meter JUMO Flotrans MAC S01 with standard PTFE lining. For optimum results, the flow rate in the Flotrans MAC should be between 1 to 10 meter per second. If it is significantly less, the existing pipeline system has not been planned economically and the pipelines are too large in relation to the flow rate. Since the measurement error is higher in the lower measuring range, a reduction in front of the MID can be installed to increase the flow rate locally. To check if the flow velocity lies within the measuring range, so-called normographs are used as they can be found in the datasheets. With a specification of DN65 and a pumping capacity of 11 cubic meters per hour, a flow velocity of circa 1.5 meters per second results. The review was positive. The MID can now be ordered in DN65. The JUMO Flotrans MAC is delivered already calibrated and is able to measure the flow of all liquids whose conductivity is at least 5 microsiemens. After mounting, the most important functions and settings can be made to configure the instrument via the easy setup. The access level can be reached by using the right soft key. Here we can select between read-only in standard view or the advanced functionality. We choose standard and select the easy setup. In easy setup we will be guided through 12 different parameters, starting with the choice of the language. Up next we want to set the unit for the flow rate. We decide on liters per minute. Thereafter, the measuring range is set. This value corresponds to the maximum current output of 20 mA. This value is used for scaling the signal for further processing in a field device such as a controller or a recorder. So the value set here is also need to set in the field device. The known capacity of 11 cubic meters per hour would correspond to 200 liters per minute. To make sure that the value not exceeds, we decide on 210 liters per minute. Beside the current output, the device also features a pulse output, as it is used for example in simple pedal wheel sensors. The unit for this output is adjusted along with the unit of the totalizer at this point. If the pulse output is to be used, we can now configure the number of pulses per minute. Again, this value also is used in the field device to interpret signals correctly. If the field device requires a minimum pulse width, this can be set here. Next, the damping can be changed. If disturbing fluctuations of the measured value occurs, the damping time can increase, which extends updating the measured value. If an error occurs, for example when exceeding measuring range or empty pipe detection activated, in addition to a binary alarm output, the current output can be set to a defined value, which can be interpreted from the field device. At first we choose the alarm signal. In the following two steps, the defined values for the currents are set. To define the system 0 point, the measuring tube must be filled with a liquid without any flow. Then the adjustment can be started. This may take a few minutes. At last, the signal cable length is set. This is necessary if the transmitter is separated from the sensor. In our case, transmitter and sensor are fixedly connected. The standard value for the cable length is 0.01 meter. Thereafter, the basic steps necessary for commissioning have been processed and the device is ready to measure.